Hello, this is a very short tutorial where I simply give you an overview of some architectural development styles in a concept level, showing you the advantages of having your code splitted by ownerships and responsibility concerns. So what is this thing of ownership and responsibility concerns? Ownership and responsibility concerns basically means that you should organize your code by modules or groups, where each module or group is responsible for a specific thing or things and owns a group of actions according to a specific business context. This is your UI, logic and data and correspondent actions should be grouped by contexts. This is the modular architecture, where you separate your actions flows by context and group of actions. This is by services, group by modules. One of the advantages of having this separated by contexts is that you can easily maintain and change your code by sections. Additionally, if each modules are independent from each other, they can easily be converted to microservices, allowing not only horizontal scalability but also vertical scalability, where modules are deployed across different physical servers and continue talking with each other. One disadvantage of the polyolithical structures, this is the module-based and microservices-based architecture, is that excessive decoupling isn't always beneficial, and it can make complex architectures harder to manage due to the increased number of dependencies. But let's first analyze the multiple types of architectural styles you may have when developing software. So I already put here multiple different styles, so I split multiple styles by decoupling styles, logical styles, tier or physical styles, and then the architecture styles, which are these ones here mixed. So related with the decoupling styles, we have layer, tier, module and service. So what is a layer? A layer is a logical separation by technical responsibility. Examples: we have the presentation layer, where you put the UI. We have the business logic layer, where basically you put your business logic codes, and then we have the data access layer, which basically is like the GPA repositories or your ORMs. Then we have the tier. The tier is a physical separation by deployment boundary. This is if parts of a system runs in different processes, containers or servers, they belong to different tiers because there is a physical boundary. Examples: imagine two layers installed in different servers. They become two tiers because now they have a physical separation of these two layers. Now, module. Module is a logical grouping of codes by business capability or contexts. A module groups related services inside the same domain boundary. Example: module user contains all the actions related with that user. This is the login, the register, the update profile, remove user, set user permissions, etc. Then we have the module articles, where this module contains all the actions related with articles. Edit article, edit, remove an article, comment an article, rate an article. Then we have other module, the module payments, which contains all actions related with the payments, pay the card, cancel payments, and whatever other actions. So modules is organizing your code by business context. Then we have the services. Services is what it is encapsulated inside of each module. So basically it is a group of business operations related to a specific responsibility that lives inside of a module. So a service implements a behavior within a module or a layer. Example: inside of a module user, you have the services add user, remove user, logging, update profile, and others. This is like decoupling style, so this is like ways to organize your code. Then we have the logical styles, how code it is organized. And this is the real structure. So after you decide to implement this in your code, then you start having these specific structures. So modular structure is when the system is organized into modules. Each module contains related services. There may be little or no layer separation inside of each module. Example: users, articles, payments, and different modules. Then we have the layer structure. Layer structure are when you have your system organized by technical layers. All presentation code is grouped together, all business logic code is grouped together, and all the data access is grouped together, so they are grouped by layers. This is no strong business modular separation as a whole, although code inside of each layer may be organized by modules. Example: presentation, business logic, a SQL layer, a data access layer. So you can organize your code by layers. When you have layers, that doesn't mean that you have module. You can have layers where you have everything together, where there is no business modular separation as a whole. So it can be everything mixed inside of layers, inside of each layer. Then you have layer first structure, where basically it's where you have the layer structure, so this layer structure here, but together with this modular structure. So you have first a layer, and then each the code is organized inside of each layer by modules. This is when the system is organized by layers, where inside of each layer the code is organized by modules. Example: inside of the business logic layer, you can have the logic code for the module user, the module article, the module payments, but inside of each module, you have only the code specifically for the business logic layer. Then you have the module first architecture, also called the feature first structure, where basically it is a modular layer structure where you may or not have inside the code organized by layer. This is when you have a system organized by modules, where inside of each module the code is organized by layers. Example: inside of the module user, you have the presentation layer, which contains the UI to login, to register, to update profile. Then you have the business logic layer with the logic code for the login, register, and update profile. Then you have the SQL layer with the SQL statements to login, register, and update profile. And then you have the data layer with the GPA repositories, or the DAO, the data access objects, or the ORMs, for the user table, permission table, and other tables. So module first structure is where you have the modules, and then you have the layer structure inside of each module. So the difference between these two is only the order. So in here you have layer first, and here you have module first. Then you have the everything mixed, where basically that's where you have when you have a system where the code is all meshed together, so there is no separation. So the presentation, the logic, the data codes are all mixed in the same files. Example: let's say that you have a web file where you have a file that contains HTML together with some logic code that connects to the database, parses the results, and show it in the HTML. Example: let's say that you have the HTML together with PHP, but that code with PHP connects with the database, parses that data, shows the data. So we have everything together, or all the layers mixed together. Another way to see this type everything mixed is inside of the presentation. Let's say they have HTML, but you have inside all the CSS and JavaScript together. You don't have the CSS and JavaScript split in different files. So that's everything mixed also. That's another way of seeing things. Then we go to the physical style. So we saw the logical styles. Now we are going to the physical styles. Basically, this is where the code runs. So this is independent if how the code is organized, if the code is organized by layers or modules. So layers and modules are logical styles. Tier styles are related to where the code runs, in which physical place. So we have some monolithic and some polyolithic structures. So monolithic and polyolithic refers to deployment, not code quality or organization. That the code quality and organization are the logic styles that mix these different decoupling styles. So monolithic structure, it's when you have a system that is delivered as a single deployable unit. It may or not be well organized internally. So this is nothing to do with the code quality. This is like a deployment. So let's say an example. So with a monolithic structure. So the example is all your code is inside of a single folder where everything must be deployed to the same place, and parts cannot be split to different servers because code, it is dependent. Parts of the code, they are not independent, they are dependent. So this is for the monolithic structure. Now let's see the polyolithic structure, also known as distributed structures or architecture. This is when you have a system that is composed by multiple independent deployable units that communicates over a network. This separation must be done by modules or layers, where the modules or the layers are independent from each other, so they can then be converted to independent deployable units, so they can be deployed to different servers. Example, you have a code that is distributed across different servers, but this doesn't mean that the code is organized by modules or layers. Let's say that if you have two independent pieces of your software that talks with each other, something like two independent softwares, but they are in the same code base, but when they are deployed to different servers, then you have a distributed system. Note that this is not microservices, because each software, it is a macro service, is not microservice. So distributed architecture is not the same than microservices. So microservice architecture is this one here, where basically you have a distributed system, a distributed structure, but with small and autonomous services aligned with the business capabilities, with the business contexts. Example, let's say that you have modules or the layers that are deployed and are independent and talk with each other across different servers through multiple requests to the services inside of each module or layer. So the idea is, inside of the modules and the layers, you have different services, micro services, that are deployed to different servers, and then they talk with each other across the network. So note that the word microservices means that each action or service is accessible through the network, meaning each access has an access point to be accessible. So micro is not macro. So don't confuse distributed architecture with microservice architecture. So microservice is a micro distributed, multiple micros distributed architectures. So then this brings us to the last style, which is the architectural styles. Basically, this is how code is organized and ready for deployment. So this is the combination of the logical styles and the physical styles. So in here is the combination of these two styles here. So architectural styles. So we have the monolithic module structure, where basically you have a single deployable unit where everything is mixed. So you can have where everything is mixed, or you can have the modular structure, or you have the module first structure. So This is a single deployable unit where you have modular structure, or the modular first structure, or everything mixed. Example. So imagine that you have your code is organized by modules, but all the code it is dependent from each other, being deployed to a single server, and to scale you need to replicate this server. So basically you have here a server, so the server 1 contains all the different modules, so the module user, the module article, the module payment, so all the modules are dependent from each other, cannot be separated in different servers. And if you want to scale, you need to replicate the whole server itself, if it will be possible, of course. Then you have the polyolithic module structure, the microservices structure, wherein here each module it is a deployable independent unit and contains multiple services. Example, the code is organized by independent modules, and each module or specific group of modules are deployed to different servers that may or not talk with each other. So you have here two servers, server 1 and server 2. In the server 1 you install the module user, in server 2 you install the module article, where the module article may talk with the module user through the network, through different access points, or the user can also talk with the module article through different access points through the network, as you can see in here. So two different modules, independent, different deployable units that talk with each other through microservices. Then we have monolithic layer structure. This monolithic layer structure is when you have a single deployable unit with the layer structure or the layer first structure. So this is the monolithic structure, it's when you have the layer structure or the layer first structure. So basically you have here an example where you have the server 1, and the server 1 contains all the layers, so the layer presentation, the business logic, or the data access layer. So this is where the code is organized in a classic 3-layer monolithic structure, with or without modules inside, where all code it is dependent from each other, so cannot be separated, being deployed to a unique and single server. To scale we need to replicate this server, so that's the example that we have here. So all these layers, the code is independent, so you cannot split these layers to different servers. This needs to be installed in just one server. Then we have the polyolithic layer structure, the microservices also. So both of these, this is based in module, this is based in layer, but both of them are microservices. So in this case, layers are deployed in separate tiers, the classic 3-tier architecture. So in here it's the classic 3 layers, in here is the classic 3 tiers. It's basically the 3 layers, but where the layers are independent, where each layer it is a deployable independently unit, but inside each layer is organized by the services as services. That's why it's microservices, otherwise it wouldn't be microservices. So example, so imagine a code that is also organized by layers, where each layer contains actions or group of actions, like the name services, but each layer is independent, allowing to be deployed in different servers. This is presentation layer is deployed to one server, business logic layer is deployed to another server, SQL layer is deployed to another server, and the data access layer is deployed to another server. Or you can have, as the example that shows here, the presentation layer is deployed to one server, and the business logic layer and the data access layer are deployed to different servers. So you have the BL1 and the BL2, where inside of each these business logic servers you can have In here you can have a specific module, one module with a specific servers, and in here you can have other module. Or you can have just simple replication, where in here you have module A and B, and here module A and B. My question, my example is, what you need to understand is, in here you have two different layers, or in this case you have each layers are independent, where in one server you have one layer, and in another server you have two other layers. So layers are independent. So that's the meaning of polyolithic layer structure. Then for last, you have the polyolithic module layer structure, where basically this is the combination of the polyolithic layer structure and the polyolithic module structure. So these two, where basically in here, in this polyolithic module layer structure, is where you have modules and layers are independent from each other, where each module, inside of each module, you have the layers, and each layer are independent, so can be deployed independently inside of each module. Or you can have the opposites, where you have each layer, and inside of each layer you have the modules, and inside and each module are also independent, can be converted to different deployable units. So basically this is the combination, as I was saying, with the polyolithic module structure and the polyolithic layer structure. So the two different microservices structures that I showed you before. Although this may sound architectural inconsistent and allow modules to be fragmented across tiers with mixed ownership boundaries, creating high network coupling and complex deployments, there could be scenarios where this may be applicable, but maybe in a more global servers overview. Let me give an example. So, first example, we have the layer first plus modules, where the modules basically represent projects. This is, imagine a server structure where you have a group of servers for presentation projects, where each server contains a project. Then imagine another server structures where you have a group of servers for business logic projects, where each server contains only the codes for the business logic corresponding to that specific project. This means, let's say that you have the project A, and then you have the presentation server PL1, where you have the UI, the code, the UI for the project A. Then you have the business logic server 1, where you have the logic code for the project A. Note that this code is not organized by microservices. And then, so you have basically the project A has two servers, where you have the presentation in one server and the business logic code in another server. Then for the project B, you have the same thing. You have one server with the presentation codes for the project B, and you have another server with the logic code for project B. So this sometimes gets confused with the polyolithic layer structure, the microservices, but it's not the same. So the main difference between the polyolithic layer structure and this structure is that with the other structure, the microservices, means that your code inside of each project are organized by microservices, which in this example that I was giving you before, this doesn't happen, because the business logic servers, the BL1 and the BL2 of project A and project B, contains the codes all mixed together, and the code runs together inside of each project, where each project contains then modules inside with the corresponding services, but these are not microservices. So even if we share a server with two projects, this doesn't become microservices, because the projects are a group with dependent macro services, not micro. So only if the BL1 and the BL2, if we convert these and deploy them to different servers, different sub-servers, running the correspondent services as microservices. Only then this architecture it will become then the polyolithic layer structure, the microservices structure. So this is for this first example, where basically you have the project 1, but in here in this server only contains the code for the presentation. In here you have the server 2 for the project B, but only the presentation codes. And then you have other server structure, where in here you have only the code, the logic code for project 1 or project A, and here you have only the logic code for project 2, project B. So you have two different, we have server structures, multiple servers with only the presentation codes. Then you have other servers with only the business logic codes, where each server contains the code for each project. This is the example here. Only if in here we split these by different servers with different modules and microservices, then this will stop to be the polyolithic module layer structure. Then this will become the polyolithic layer structure with microservices, which is not, in this case, is not the case, because the code, all the code inside of the business logic runs in just one server. Okay, so this is the first example, layer first, and then the projects, which basically the projects are like modules, or modules with sub-modules inside of projects with modules inside, whatever. But this is just an example if you have a global overview to understand how this is also possible, and also it makes sense. Then another example, it is opposite. Instead of being layer first, you have the module first, and then inside you have the layers. So example, so imagine a server structure where you have a group of servers for different modules. So you have, so this is like, imagine this as being like horizontal and this vertical. So where you have a group of servers for the module user and another group of servers for module article. This is where inside of each module then you can have this code split in layers. So inside in here you have the code for the UI, the code for the business logic, the code for the data access logic. You have these separates in layers, but the layers in here are independent and can be installed in different servers. So in here, in the module user, you have here the server with the presentation layer, but the code in here is only correspondent to the module user. And then the server talks with another server, which is the business logic server 1, that contains the business logic code for the module user. And then in here you have the module article with the server 2, the PL2, that contains a presentation layer code for the module article, that connects with another server that contains the business logic code for the module article. So you have the module user with two servers, the presentation server 1 and the business logic server 1. And you have then the module article with the presentation server 1, in this case server 2, and the business logic server 2. So this sometimes gets confused with the polyolithic module structure microservice. So this gets confused with this. But the difference is that this is microservices. So the code in here doesn't mean that it's organized by microservices. The main difference is that in here all the layers are installed in just one server. This architecture, each layer is installed in different servers. So in the polyolithic modular structure, each server contains all the 3 layers installed in here. In here, the layers are separated, so you have more decoupling. So as you can see in both of these examples, They are very similar, but this depends the way you look to the responsibilities. If you look on a horizontal way or on a vertical way. This is, if you look on horizontally, then the architecture is based in modules. So if you look horizontally, then the architecture is based in modules. If you look vertically, then the architecture is based in layers. Even so, layer first, even if they are microservices, where each module became then the projects with modules inside. So in here you don't have really microservices, as I was explaining before, because then the code is together installed all together in here, corresponding for that specific project. Now that we understand all these concepts, depending of the architecture style you decide to implement, so depending of the architecture styles, all these styles here, you have different advantages and disadvantages. What this means that you must analyze carefully your business needs and make the correct decision according with your requirements. Why is that? Because too much decoupling is good because the code gets organized and gets with different ownerships and responsibilities, but it brings also too much complexity, deployment complexity, maintenance complexity, and this can become a pain in the ass. More, if you add here architecture based in event-driven structures, that becomes even more complex. And if you have all this decoupling plus the event-driven, that can become very difficult to manage. So just keep in mind this. I know that this last one, it is a little bit confused, so this last one here, because it mixed some of this, is too much decoupling. As I was saying, it could sound architecturally inconsistent and allows modules to be fragmented across tiers with mixed ownerships boundaries, creating high network coupling and complex deployments. I know that can really happen. So that's where, but there are some, if you have a lot of different projects for a lot of different clients and you want to have this in all together in the same server architecture, maybe you may think about something like this. Otherwise, you need to analyze carefully, because maybe you don't need something like this so complex, because then it can bring you other issues, other problems. So try to avoid this if possible. If not, this is just an example. So these styles are, I'm just explaining this in a conceptual level, so you can understand all these different concepts. Now, some keynotes that you need to understand. So I know that the architecture styles can be confused because they are mixing all of these, but the important thing that you understand basically is these three. It's the decoupling styles, where you have the layers, the tiers, the modules, the services. Then you have the logic styles, where you have the modular structure, modules, the layer structure, or the layers with modules inside, or the modules with layers inside, or everything mixed. Not advisable. This is not advisable at all. So that's for the logic styles. Then you have the physical styles, where you have the monolithic and the polyolithic styles. So then you have the architecture styles, that's the deployment. That's when you mix all these three. That's the different type of mixes. That's when you create the different architecture styles. That's what we did in here with all these different styles. That's mixing all these three. So the important thing is you know these three. Then this is just names, concepts that you are mixing this. If you know this, automatically you understand this by default. Now, another keynote that you also need to keep in mind, which are microservices are not the same than distributed systems. They are distributed systems, but the distribution system is not the same, doesn't mean that it is a microservice. This is just because you have a distributed system, this doesn't mean you have that structure in microservices. You can have it in microservices. Microservice, as the name says, it's micro. It's an action or a service that it is accessible through a network, meaning that that action is accessible as an access point to be accessible, but it's a micro. It's multiple different micro services that are accessed through different endpoints and are independent from each other. That's the meaning of microservices, not macro. So distribution system doesn't mean that is in microservices. You can have distribution systems with microservice, as I was explaining you before in here. This you have all the project installed in the macro service, different layers, and the same in here. So that's macro service. So distribution system is not microservice. That's why I put here, this is microservice, polyolithic layer structure, independent then if inside or is organized by modules or not. And this is the polyolithic module structure microservice, where inside independent of inside of each module if they are organized by layers or not. But it's organized by microservice. And that's it. Basically, I end this tutorial. This was just a simple overview just to explain you different type of styles of organizing and deploying your codes. So it's very important. I know that when you are coding, you are not thinking about deployment. You only think about deployment after you code. When you are thinking, how then can I put this in my servers to be scalable? But that's why it's important you understand all these concepts, because if you organize your code correctly with independent modules or independent layers, you'll see that for the deployment is much easier. What's the my recommendation? Organize your codes based in modules, and inside of modules you organize based in layers inside. That's the idea. So before, in the few years back, the people like to use the layer first, which will be the layer first architecture. Where is it? In here, layer first structure. Now it's more common the people to use instead the module first structure, where basically you have modules, and inside of module you have the code organized by layers. So it's the module first, where then you have the modular layer structure inside. So then you can deploy each individual module to different servers, where then you have the microservice, which is this one, the polyolithic module structure. So this is the most current type of structure that the people use nowadays. Also, if you want to have too much decoupling, where inside of each module you have independent layers, then you go to the polyolithic module layer structure that I was explaining you before, which in this case will be this one here. That's it. So just keep in mind, but my recommendation is probably this will be more than enough for 90% of the cases. And that's it. So this is the tutorial explaining you different code structures, organization, and ready to be deployables. That's it. So thank you very much.